Hello, everyone. Um, Welcome back to the fourth session of mathematics session of the Study Ready program. So this session is on strengthening your algebraic skills, and in particular, we're gonna review the arithmetic of algebraic fractions, and also we will explain how we can rearrange formulae. So here is an quick overview of the session. So first we're gonna go through the arithmetic of algebraic fractions, do some examples there, and then we're gonna move on to the topic of rearranging formulae. At the end of the session, I will recommend some resources you can use if you want further practice. Okay, so resources for further practice. Okay, let's start with multiplication and division and simplification of algebraic fractions. First, what is an algebraic fraction? So an algebraic fraction is a fraction that contains algebraic terms. So contains algebraic variables. So 1 over x is an algebraic fraction. 2 times y over x squared is also an algebraic fraction. 5x over 7 is an algebraic fraction. We have the term x here. Minus x plus a over y is an algebraic fraction. 17 plus f over minus w is an algebraic fraction. X plus y over y to the 4 is an algebraic fraction. So these are examples of algebraic fractions. There are fractions that contain algebraic terms. In general, the standard algebraic operations that we have for numerical fractions or algebraic fractions can be applied to algebraic fractions. So for example, if we want to multiply two algebraic fractions, we just multiply numerators together and denominators together. So a over b times c over d, it's a times c over b times d. Now for division, we again apply the same rule that we apply when we want to divide arithmetic fractions. So if you have 1 over a over b divided by c over d, then we invert the second fraction and we multiply. So the division becomes multiplication, given that we swap numerator with denominator of the second fraction. So this becomes a times d over b times c. Now, in many cases, we have that a common factor appears in both the numerator and the denominator. Common factors can be cancelled. Okay, so we can simplify algebraic fractions. Let's do some examples. So let's start with this one. And let's carry out the multiplication and division, and if it's possible, simplify as well. So we have 4 over 5 times x over y. So what is the rule for multiplying fractions? We just multiply numerators. So 4, I will write it like this. So 4 times x over 5 times y. This you can write it just as 4x over 5y. Okay. Same here. So 1 over b times a. Now a, so let me write it like this. So 1 over b times, so a, I can write it as a fraction if I have denominator 1. So a over 1. Okay, so any number a, you can write it as a over 1. And then you just apply the multiplication rule. So 1 times a over b times 1. So this is just a over b. So this was the second example. Let's do the third one. The third one is 1 over b divided. Let's first write a as a over 1. And now let's apply the rule for division. So 1 over b stays as it is. Division becomes multiplication. And we swap numerator and denominator of the second fraction. So 1 over a. And now we do the multiplication as usual. So 1 times 1, b times a. We can write this as 1 over a b. So 1 over b divided by a is just 1 over ab. Okay, let's move on to the fourth example. So we have 4x times 3y over 16. So we have multiplication. We multiply numerators with denominator, x times 16. And now here we can also simplify. So 4 goes to 16 4 times. So we get a 4 here. So this we can write it as 3y over x times 4, or 3y over 4x. So here we have common factor 4. Okay, let's do example 5. So 10 times a squared over b divided by a squared over 3b. So let's first apply the rule for division. So the first fraction stays as it is. So 10a to the square over b, division becomes multiplication, and then we change numerator with denominator. So we have 3b over a squared, and let's apply the multiplication rule. So 10a to the square times 3b over b a to the square, and we see that we have a to the square in our numerator and a to the square in the denominator. So here we can just simplify. These two can cancel. 3 times 10, this is 30. B over b. We also have b. So here we can also simplify b. So we just get 10 times 3. So we just get 30 only. So a lot of simplification here. So equals to 30. Okay, let's do some more. So example 6. So here we have 5 times the algebraic fraction x minus 3 over 25. Okay, so let's do it step by step. So let's first write 5. So I'm going to write 5 as 5 over 1 times x minus 3 is the numerator, 25 is the denominator. So let's do numerators with numerator. So 5 times x minus 3 over 25. And again, here we see that we can simplify 5 with 25. We get a 5 here. So it's just x minus 3 over 5. Okay. Have some more examples here. So let's do 7. So 7 is again a multiplication of algebraic fractions. So let's multiply numerators with denominators. Okay. So we have x plus 2 times 4p y minus 3. Nice. Over minus 3 plus y times 5q x plus 2. What can we simplify here? So first we see that we have x plus 2 and x plus 2, numerator and denominator. So here we can forget this. 4p y minus 3. The bracket minus 3 plus y, we can write it as y minus 3 as well. Okay, it's the same thing. So y minus 3. And then we get 5q. So we can simplify this bracket too. So we have 4 times p over 5q. Okay, so the next example, we have division. So we start writing the first fraction as it is, x to the square times y to the power of 3 over z. Division becomes multiplication, and then we exchange numerator and denominator. So we have x over y. Let's carry out the multiplication. X to the square, y to the power of 3 times x, z, y. Okay. Here we have y to the power of 3 over y. This means that I can simplify one y. So this would become y to the square. X to the square times x will give me x to the power of 3. I get the y to the power of 2, and I get a z in our denominator. Okay, let's do example 9. So 3. Again, here we see that we have division. So let's write the first fraction, p plus q, z to the power of 3 over z plus q. Division becomes multiplication. We swap numerator with denominator, so we have z plus q, z plus q, and we have 9z. Okay, let's write the multiplication. So we have 3, I will write z to the power of 3, p plus q times z plus q over. I will write this as 9z times z plus q. Okay, so what can we simplify here? There are a lot of terms that we can simplify. So first, the bracket. Z plus q, we can simplify. Now, z with one of the z's from the z to the power of 3, we can simplify. It will leave us with z to the power of 2. And 3 with 9, here we're going to get 3. So this is equal to, z squared p plus q over 3. So this is the result. Let me write it here. So this is equal to z to the square p plus q over 3. Let's do this final example. Here we have multiplication, so we just multiply numerators with numerator with numerator, denominator with denominator. Okay, let me write it first. So we have minus 15 a to the square minus b to the square x plus y over x to the power of 2 plus 2xy plus y to the square times 3a minus b. Okay, so first of all, we can simplify 15 with a 3. Okay, so 3 to 15 goes 5 times. So let's rewrite the result. So this is equal to minus, okay, the minus can go in front of the fraction, minus 5a minus b to the square x plus y. And then we have x to the square plus 2xy plus y to the square times a minus b. Can we simplify any terms here? Although it's not very obvious, but if we use some algebraic identities, so recall that a to the square minus b to the square is equal to a minus b times a plus b. So a to the square minus b squared can be factorized into two terms, a minus b times a plus b. And the term here, x squared plus 2xy plus y squared, this is equal to x plus y to the power of 2. Okay. So we can use these two identities and simplify even more our fraction. So we have minus 5a minus b. I use the first identity, so a to the square minus b squared is a minus b, a plus b, and I have x plus y. X to the square plus 2xy plus y squared. This is x plus y to the square. And then I have a minus b. So here I can simplify, first of all, a minus b, and x plus y with the square here. So I get minus 5 a plus b. This is the only term that we have in the numerator, and x plus y. Okay, so these were some examples with multiplication and division and how we also can simplify, how we can use, for example, algebraic identities to simplify algebraic fractions. Now let's go and do some examples with addition and subtraction. First, let's recall that in order to add or subtract numerical fractions, we need to have common denominators. If we don't have common denominators, then we convert each fraction to an equivalent form with the same denominator, if not. And then we just add the numerators. For example, if I want to add 2 over 5 plus 4 over 7, what I can do is to write the first fraction as 2 times 7. So I multiply with the denominator of the second fraction times 7 plus 4 times 5. So I multiply now with the denominator of the first fraction 7 times 5. So whenever I multiply if I multiply the denominators, I will get a denominator. I will get equivalent fractions with the same denominator. So here I have 14. 5 times 7, 35. Plus 4 times 5, this is 20, 35. So you see we have now same denominators. And I can just add the numerator. So 14 plus 20. So 34 over 35. This is how you can add numerical fractions. And the same rule applies to algebraic fractions, even if you add or subtract. So the method, so if we want to summarize, so adding or subtracting algebraic fractions, if the fractions have the same denominator, then we just add or subtract the numerators. If the denominators are different, then we find a common denominator and convert each fraction in equivalent form which has the same denominator. In practice, it's a bit more simple. Okay, so let's do some examples. So let's say we want to add 2 over x and 5 over x. Here, because we have same denominators, we can just write the fraction with denominator x, and then we just add the numerator. So this is just 7 over x. What about the second fraction? So here we subtract 17 over zy, we subtract 11 over z, not y, w. Again, the numerator is the same, so we keep the numerator as the denominator is the same, so we keep the denominator as it is, and we just subtract the numerator. So this is just 6 over zw. Let's do example 3. So this is so for example 3, we can see it as the general case of adding algebraic fractions. So we have a over b plus c over d. Now, a over b, I can write, so if I multiply numerator with d, I multiply denominator with d. Okay, so I do a times d over b times d plus c times b d times b. I multiply numerator and denominator with b. So now I have the same denominator. I can write it as b times d. And then I just add the numerator. So a times d plus c times b. Let me do a note here. Why a over b is equal to a times d over b times d. So if you have a over b, this you can write as a over b times 1. Okay, I just multiplied with 1. It's okay. Now 1, I can write it as d over d. Okay, so d over d is equal to 1. And now I multiply two algebraic fractions. So what do I do with multiplication? I multiply numerator with numerator, denominator with denominator. So a over b, let me write it like this. A over b is equal to a times d over b times d. And the same is for c over d. Okay, so same calculation. So this is how you can go from this fraction to this equivalent form of the fraction, where now your denominator is b times d. Let's do the same for example 4. So we have 3 over 4 plus 1 over x. So here we have different denominators. So we want to convert each fraction into a form that into the form that we have same denominator. What we can do is to multiply the first fraction, the numerator of the first fraction, with the denominator of the second fraction, and we do the same for the denominator. Now we take the second fraction and multiply numerator and denominator with the denominator of the first fraction. So times 4x times 4. So you see we have now same denominators for x, and we can just add the numerators. 3x plus 1. Let's do 5. So for 5 here we notice again that we have different denominators. However, in the first fraction, so the first fraction has denominator y, the second one has y squared. So if in the first fraction I just multiply numerator and denominator with y, so y times y, and I leave the second fraction as it is, you see that now we have 3y over, so y times y is y squared. So I get same denominator, 3y plus 4 over y squared. Okay. Let's do example 6. So here we have subtraction, but again, we subtract as we add algebraic fractions. So the rule is the same. We need to convert to same denominators. So here we just need to multiply the first fraction, numerator and denominator, with the denominator of the second fraction, which is p, minus, I do the same. I write the second fraction, p 5 over p. I multiply numerator, denominator with the denominator of the first fraction, with a q. So now I have q times p times q is the same, so p times q, and I subtract, so 6p minus 5q. So 6p minus 5q over pq. Let's do 7. Again, we have different denominators, so let's write the first fraction, x plus y. We multiply with the denominator of the second fraction, 3 x plus y times x plus y. So now again, we have same denominators. So I can just write it as y x plus y. And then we just subtract the numerator. So we have 4y minus 3x plus y. And you can even expand the bracket. You're going to have minus 3x. So you're going to have y minus 3x over y x plus y, for example, if you want to simplify a little bit more the numerator. So 3, we're going to have minus 3x. Here it is, minus 3y. But we also have the 4y, so we just get only 1y in the numerator. Okay, let's do example 9. Again, we have different denominators. So what is the idea? We write the first fraction, x plus 3. We multiply with the denominator of the second one, so x minus 1, x minus 1. Plus, let's write the second fraction, 5, x minus 1, and we multiply with the denominator of the first fraction, x plus 3, x plus 3. So here we have now same denominators. So we have x minus 3, x plus 3. And the numerator is 2, x minus 1 plus 5, x plus 3. You can expand the brackets. So let's expand the brackets. Let me do some space. Let's put some space here. Might need some more space here. Okay, so here we have x minus 1, x plus 3. So 2 times x minus 2. So 2 times x minus 2 plus 5x. 5 times 3, this is 15. So here we can write it as x minus 1, x plus 3. 2x plus 5x, this is 7x. 15 minus 2 plus 13. So this is your result. Okay, let's do 10. So for 10, again, we have different denominators. In order to convert its fraction to an equivalent form with so that both of them have the same denominator, what we can do, we can take the first fraction, 2q, p plus q, multiply with the denominator of the second fraction, both numerator and denominator, so times p, minus q and p, and we multiply with p plus q times p plus q. So this will give us 2pq minus q, p plus q, and then we have p plus q. Okay, let's continue the calculation. So p plus q, and we have 2pq, and then we have minus q times p, q times p, minus q times q, q squared. Okay. So here we can see that we have just, so 2pq minus qp or pq. So this is just 1 pq minus q squared p plus q. Okay. And here we can also have common factor q. So we have q p minus q over p plus q. Okay, so this is how you can simplify also the result. Okay, let's do 11. Again, for 11, we see that we have 1 over x minus 4 plus 1 over x minus 4 to the square. So if I want to have same denominators, I can just multiply numerator and denominator of the first fraction with the x minus 4. So I can write this as 1 x minus 4 over x minus 4 x minus 4. And I keep the second fraction as it is, x minus 4 to the square. So now I have x to the minus 4, x minus 4 to the square, plus 1 x minus 4 to the square. And this will give me x minus 4 plus 1 over x minus 4 to the square. So x minus 4 to the square is our denominator, x minus 4 plus 1, so minus 4 plus 1, minus 3. Okay. Okay, now we need to do a little a longer computation, and we see that we have 3 terms. So here first, let's so we have denominator x plus y, x minus y, and we do minus 2. Okay, so how we can go about this calculation? Let's first only add the algebraic fractions, and then we're gonna subtract the 2. So let's do it step by step. X minus y, x plus y, plus x plus y over x minus y. Here we see that we have different denominators. What we do in this case, we multiply, we write the first fraction, and we multiply numerator and denominator with a denominator of the second fraction, so with x minus y. So x minus y. Plus, let's write a second fraction, x minus y, and we multiply with a denominator of the first fraction, so x plus y, x plus y. So now you see we have same denominators. Okay, very good. So here we have x minus y to the square plus x plus y to the square, x plus y, x minus y. We can carry on with a calculation. So so remember that x minus y plus minus y is equal to x squared plus minus 2xy plus y squared. So let's apply this formula here. X to the square minus 2xy plus y squared. This is the first bracket only. And also remember that x plus y, x minus y, this is also x minus y to the square. So here we have x to the square minus y to the square. And here we have x squared plus 2xy plus y squared. We can see that we have some cancellation, so we can cancel. So we have x squared and x squared, 2x squared plus 2y squared over x squared minus y squared. So x minus y over x plus y plus x plus y over x minus y, this is equal to 2x squared plus 2y squared over x squared minus y squared. Now, what we want to calculate is the following: x minus y over x plus y plus x plus y, x minus y minus 2. But we know that this part is equal to 2x squared plus 2y squared, x squared minus y squared minus 2. So it remains to do this subtraction. How we can do this? So again, let's write the first fraction as it is. So 2x squared plus 2y squared x minus y to the square minus 2. I can write it as 2 over 1. And if I want to have same denominators, I need to multiply with the denominator of the first fraction. So now you see that you have 1 times x squared minus y squared is the same as x squared minus y squared. So we have same denominators, so we can subtract the fractions. Minus 2, like this. Okay, let's do a couple of more steps. So we have 2x squared plus 2y squared minus 2x squared minus minus plus 2y squared over x minus y squared. So x squared minus y squared, and the numerator here we can cancel. 2y squared plus 2y squared, this is 4y squared. So we saw that x minus y, x plus y plus x plus y over x minus y minus 2. This is 2y squared, x squared minus y squared. Okay, so this was the last example with on the addition and subtraction of algebraic fractions. Essentially, remember that if you don't have, if you have two algebraic fractions and you want to add them or subtract them, you need to convert to a form that both of them now have the same denominator, and then you just add the numerators. This is the whole idea. Let's move on to the second topic, which is on the rearrangement of formulas. So first, a mathematical formula is essentially an equation that expresses the relation between various quantities. For example, if we have a formula for the perimeter of a circle of radius r. So if you want to find the perimeter of a circle, so this is a circle, this is the radius, here is the perimeter. So the perimeter C is given as 2 pi times r. Okay, so this is a formula. The subject of this formula is the perimeter, the C, where usually, so the subject of a formula appears by itself only on one side of the equation. So here we use, and usually on the left-hand side of the equation. Okay, so the subject now here is C. However, in many cases, we are given a formula, but we need to rearrange it so that, or we need to change the subject. And to change the subject, we rearrange or transpose the formula. So for example, if we want to rearrange the formula for the perimeter of a circle to make the subject the radius, we can write it as r equals the perimeter over 2 pi. How we can transpose a formula? So again, we follow the same ideas as solving an equation. Okay, so we need to solve for a new variable, for r. What we should keep in mind is that whatever you do in one side of the equation, you do to the other side. Okay, so in order to keep the balance. So whatever you do to one side, you must do to the same one. So you can subtract the same term on both sides. You can multiply or divide both sides with the same term. You can apply operations on both sides. So for example, you can take the square, you can take the square root, logarithms, exponentials of both sides. Let's do some examples to see how we can go about the rearrangement of formulas. So here we are given the formula for the perimeter of the circle. So the perimeter is 2 pi r, and we want to make now r the subject. So essentially we want to write down that r equals. So if I want to isolate r, because 2 pi multiplies r, if I divide both sides with 2 pi, we see that on the right-hand side, 2 pi and 2 pi is simplified. So here we have c over 2 pi equal r, or r equals c over 2 pi. So this is an example of rearranging a formula. So you start with a formula, your subject is the perimeter is c, you rearrange it to make the radius the subject. So now r is the subject of the formula. Let's say we are given the formula y equals 7x plus 5, and you want to now solve or rearrange the formula for x. So we want to write x equals. Let's take the formula. We want to isolate x. To isolate x, first what we can do, for example, is we can expand the bracket. Okay, so from here, y is equal, so you multiply 7 with x and then with 5. So it's 7x plus 7 times 5, this is 35. Okay, So we x is here, 7x. We want to get rid of the 35 first. So if I subtract 35 from both sides, here I'll get 0. So I'll get y minus 35 equals 7x. And now I want to get rid of the 7. 7 multiplies x, so I do the opposite. I divide with a 7. So if I divide with a 7, I have y minus 35 over 7 equals 7x over 7. So 7 can simplify. We get x only. So x is equal to y minus 35 over 7. So we started with a formula where the subject is y. We rearranged it. To make x the subject. Let's move to example 3. So here we have a formula which says w minus q equals 4 times the bracket y minus 2. We want to make y the subject of this formula. So we want to write y equals. Okay, so y equals something. Again, the first we can do is to expand the bracket. Okay, so that we can have y for y on its own. So w minus q equals 4y minus, so 4 hits y, 4 hits minus 2. We have a minus, so minus 2 times 4, 8. Super. Let's get rid of the minus 8 here because we have minus 8. If I add 8 in both sides of the equation, then on the right hand side, I will just have only 4y. 8 will give me 0. And now I have 4 times y here, so I want to get rid of the 4. 4 multiplies y, so if I divide with a 4, 4y over 4, then for numerator and denominator we can simplify, so we get that y equals w minus q plus 8 over 4. So we had this formula, we rearranged it to make y the subject. Okay, let's go to another example. So we want to rearrange for x. So this is the equation of a straight line. Okay, so we want to rearrange for x. Again, we start with y equals mx plus c. C is a constant. We want to get rid of c first so that we can only have m times x. So if I subtract c from both sides, c minus c, here I will get 0. This means that I have y minus c equals mx. So now because m multiplies x, which is the term that we want to make the subject of this formula, so we can divide with m. But when I divide one side, I need to divide the other side too. So here we can simplify m, and we get x equals y minus c over m. So starting with a formula for y, we rearranged it to make x the subject. Okay. Now let's move on to example 5. So here we want to rearrange again for x. Maybe this looks a little bit more complicated, but let's start by first expanding the bracket. So we have x outside the bracket and x inside the bracket. So let's expand the bracket. So x times 1 plus x times 1 over x. Okay. Now what is x times 1 over x? This is like multiplying algebraic fractions. So this I can write it as y equals x plus x over x. So this is 1. So this is like y equals x plus 1. And then I just need to rearrange for x. So let me get rid of the 1 first. So I subtract 1 from both sides. This will give me 0. So I end up with just x only equals y minus 1. Okay. Let's do example 6. Make x the subject of this formula. So x now is here in the denominator. Usually when you have this situation, you want to have x on top of the equation. So here we have y equals 4x minus 7. What we can do to have x on top, so here we can just multiply with x minus 7. So if I multiply both sides with x minus 7, here I get 4x minus 7 times x minus 7. And x minus 7, we can simplify. Okay, so we end up with y x minus 7 equals 4. We want to solve for x. We want to make x the subject. So let's expand the bracket. So we have y times x minus 7y equals 4. Okay, so y hits x, y hits 7. 7 times y does not depend on x, so I can take it to the other side. Okay, so I can add both sides with 7 times y. So yx minus 7y plus 7y equals 4 plus 7y. So this will give me 0. And I have y times x equals 4 plus 7y. Now I want to isolate x, so I want to get rid of the y. So if I multiply both sides with y, I get x equals 4 plus 7y over y. And this is how you can rearrange this formula for x. So we had the formula where the subject was y. We rearrange it to make x the subject. Okay. Let's do example 7. So for 7, we have a formula for w. We want to rearrange the formula and make z the subject. This looks a little bit more intimidating, but again, first we want to get rid of the z here in the denominator. To get rid of the denominator, we multiply both sides of the equation with a denominator. So if I multiply with 1 plus z squared, both sides, so 1 plus z squared times w, this is 1 plus z squared. So what is w? W is 1 minus z squared over 1 plus z squared. So 1 plus z squared, 1 plus z squared, we can simplify. And here let's expand the bracket. So 1 times w, z squared times w. So 1 times w, w plus z squared times w. This is equal to 1 minus z squared. Okay, we want to solve for z. So the idea is that on one side, we only have z, and in the other side, we only have 1 or w. Okay, we have the terms that they do not depend on z. So let me first add z squared to both sides. So here, if I add in this side z squared, I will get 0. So, and I will have z squared here. So w plus z squared times w plus z squared minus z squared. plus z squared. So here I will get 0. Okay. Let me add some space here. And some space here. Some space here. Okay. We have some more examples to do, but I think in total we have 11 examples. Okay. So here we have w plus z squared, w plus z squared equals 1. We want to solve, so remember, solve for z. So let's get rid of the w. So if I subtract now w from both sides, then this w minus this w will give me 0. So we don't have w. We have z squared w plus z squared equals 1 minus w. Okay. How we can solve for z? So first, let's solve for z squared. Okay, if I have a formula for z squared, then I can take the square root and have formula for z. So here I can take common factor z squared and have w plus 1. Indeed, z squared times w will give me this term, and z times 1 will give me this term. Okay, so I have z squared as common factor here. This is 1 minus w. So we have z squared w plus 1 equals 1 minus w. Let me continue here. I want to get rid of the w plus 1 bracket, okay, this bracket. So I want, because it multiplies z squared, I will divide. So if I divide both sides with w plus 1, here I would have 1 minus w, w plus 1. Here I can simplify, so I get z squared equals 1 minus w, 1 plus w. Now, because z to the power of 2 is 1 minus w over 1 plus w, z can be either plus or minus the square root of 1 minus w wait a minute. So let me write it like this. So now if we take the square root, I'll get the absolute value of z is equal to 1 minus w, 1 plus w, the square root. Given that this is greater than 0. So z can be plus minus the square root of minus w, 1 plus w. Okay, so let's now move on to the next example. So 8, we have the volume of a sphere of radius r. This is given by this formula. So the volume of a sphere, so if you have a sphere, the volume is 4 over 3 pi r to the power of 3 for the radius. So we want to rearrange the formula to make r the subject. Okay, so first, let's multiply with a 3, because I want to get rid of the 3 here. So 3, 3, 4 over 3 pi r to the power of 3. Okay, so 3 and 3 here we can cancel. And we have 3 times v equals 5p r to the power of 3. So what we can do here, so here, because we have 4 pi multiplying the radius to the power of 3, we want to get rid of the 4 pi. So 3, because we multiply, we can divide. So if I divide both sides, then I have that that r to the power of 3, this is 3v over 4 pi, which means that r is equal to 3v 4 pi 1 over 3. So this is how you can solve for the radius. Okay, let's do example 9. So for 9, so here we have the conversion between Celsius degrees to Fahrenheit. Okay, so if you know the degrees in Celsius, you can find the degrees in Fahrenheit. So by this formula. So F is equal to 32 plus 9C over 5. Let's rearrange so that we have the formula, so that we have the subject now is C, the degrees in Celsius. Okay. Let's get rid of the 32 first. So always get rid of the constant. So because we are adding 32, so this is positive, we need to subtract it from both sides. So we have 32 plus 9C over 5 minus 32. This means that I have F minus 32 equals 9C over 5, because 32 and minus 32 will give me 0. Okay, now let's get rid of the 5. Because 5 divides 9C, we can multiply both sides of the equation with the 5. So let's multiply with the 5. And now this 5 and this 5, we can simplify. Let me go here. So we have 5 Fahrenheit minus 32 equals 9C. And now because 9 multiplies C, if I divide with a 9 both sides, here we can simplify. So I have 5F minus 32 over 9. So C equals 5 times F minus 32 over 9. So we have rearranged the formula so that if we know the degrees in Fahrenheit, we can find the degrees in Celsius. Okay, I think we have 2 more examples. So for example 10, we have that the period t of a pendulum of length L is given by this formula. So the period is equal to 2 pi times the square root of L over g, where g is the gravitational constant. We want to transpose this formula to make L the subject. So here is L. Let's rewrite the formula. So let me rewrite here. So the period is 2 pi square root of L over g. Okay. Okay. Now, because L is under the square root, first we want to get rid of the square root. Or if you want, first, let's get rid of the 2 pi so that we only have the square root of L over g. 2 pi multiplies the square root. So if I divide both sides, I can get rid of the 2 pi. So I have 2 pi over 2 pi square root of L over g. 2 pi, I can simplify, so this will be equal to 1 times the square root. So we have e over 2 pi equals the square root of L over g. Now, what is the opposite to the square root? Is the square. Okay, so now if I take the square, it will cancel the square root. Okay, so if I take the square, so the period over 2 pi to the square is the square root of L over g to the square. But square and square root, I can simplify. So we have period over 2 pi to the square equals L over g. And now because g divides L, we want to solve for the length for L. If I multiply both sides with g, we see that g here simplifies, and the length, now we get the formula for the length is g times t 2 pi over 2 pi to the square. So we had a formula for the period t, we rearrange it to make it a formula for L, and we want to rearrange the formula. Usually we do the opposite operation in order to isolate the new subject of the formula. Let's do our final example. So here we have a particle with initial velocity u, constant acceleration a, and travels at the distance s in time t, where the initial, so particle with initial velocity u and constant acceleration a travels at the distance c in time t. So here with initial, this is the same, so sorry. So the formula, so a particle with initial velocity u and constant acceleration a travels at the distance n in time t, and the formula is given by this. So so the distance s is given by u times t plus 1/2 times the acceleration times t to the square. We want to solve for u, so we want to solve for this term. So you have a particle that is moving with initial velocity u at a constant acceleration a, and it covers a distance s at a time t where the distance is given by this formula. We want to solve for the initial velocity. Okay, so we have s equals u t plus 1/2 a t squared. Where is u? U is here in this term. So let's first isolate this term. What we can do, we can subtract this term from both sides. So if I subtract this term from both sides, what do we have? We have minus 1/2 acceleration t squared. So here we'll get a 0. So we end up with s minus 1/2 a t to the square equals u times t. So if I want to solve for u, this will give me s a t squared. I need to divide with t. So here we can cancel t. So the initial velocity is s minus 1/2 a t to the square over t. So this is how you can rearrange the last formula. Now, if you want to have some further practice, you can visit the links here. So arithmetic rules of algebraic fractions, that's fun. Essentially, you can find all these links if you go to the study ready guide. So let me open this link. If you go to this link, you can find the notes over here. So if you go to the math program, strengthening your algebraic skills, and you go to the last page, you can find all these links, worksheets from the Math Center for Maths Fun, how to rearrange formulas, how you can use the arithmetic rules of algebraic fractions. And if you would like more support with your math studies at LSBU, you can visit our homepage, find out more information. Thank you for watching the video. I'm gonna stop the recording now. Thank you.